Hi, my name is Spoons, and this is the Lightning Talk version of 6 ways configuration systems fail. As I said in the longer version of this talk, my experience is in configuring production software systems, so that's what I'm going to talk about today. And I wanted to share my experience in the spirit of a blameless postmortem, so this is not about pointing fingers, but about doing better next time. The first 2 ways that I've seen configuration systems fail is when we think about the configuration system too narrowly, and especially when we think about the configuration language without the context in which it's used. So the first case is, while I think it's pretty easy to make the case that a configuration language should be strongly typed, that strongly typed doesn't really mean much if the types don't accurately reflect what's really expected of the configuration. And this happens a lot since configuration is often packaged and repackaged as it's passed from one component to another. I gave an example of this where Kubernetes can be used to forward configuration to an application, but out of the box, it doesn't do anything to help you validate it. The second way I've seen these systems fail is where, as a language designer, we focus too much on the definition of the language itself and get distracted from all of the tools, documentation, and other things outside of the language that help make it successful. And getting dragged into conversations about whether or not a configuration language should be Turing complete is sort of the worst offender of this, for myself included. That time's better spent building, for example, a great debugger, because you'll need a debugger regardless of the computational expressiveness of the language. I've also seen configuration systems fail when the maintainers think of the language as the only way of interacting with the system. When that's the case, it often leads to fragile automation that's built on top of that language. And why is automation important? Well, it's a critical part of operating production systems at scale. It's how we do things reliably over and over again. It's how we recognize and act on outages or other issues when we detect them. And I used an example slightly out of the realm of production software as an example. I talked about configuration languages, a configuration language that's used to compile and link many software projects, that is Makefiles. Makefiles are written in a domain-specific language used by people, but that language is also the target of several different tools. It's the output of those tools, like AutoConf or CMake. And when we have this case where we have both humans and automation systems using a language, I think it makes everyone's life more difficult, including the maintainer of that configuration system. And I think any successful configuration system will ultimately become just one component of a larger system. So this is something that you should at least plan for from the beginning. Incremental change is another area that's really important, and this is a place where I've seen configuration systems fail. Users will use configuration to specify incremental change. It's how we manage risk in production systems. But if the configuration language doesn't support that, it'll be painful. If it is supported, everyone will benefit. And I talked through an example of how Kubernetes resources are built and combined to do this sort of thing effectively. Finally, configuration has a long lifetime and plays a role in many different processes. Unlike source code, which is usually the responsible of just a handful of people, at least for any particular piece of source code. Obviously, lots of source code has lots of different authors and testers and things like that. But unlike source code, configuration plays a part in the responsibilities of many different job roles, from developers to QA, but also change managers, operators, site reliability engineers, and other folks as well. And I talked about not only does it play a role in each of these, does the configuration has a part in each of these different jobs, but also how those job roles have competing needs. So for example, one of those jobs might want configuration to be easily bundled into larger and larger packages, while another role might actually want to have fine-grained control and to divide the configuration into many small parts. One role, for example, developers might want that configuration to be stored alongside source code, while someone on the operations side might want it to be stored in production. And if we meet both of those needs, then we'll have to deal with the fact that it's stored in more than one place. So, in summary, before you design a configuration, make sure that the language, a new language, is really the right tool for the problem you're trying to solve. Maybe there's other ways to solve that problem using an existing API or building a new one. And if you are designing a configuration language, think about other parts of the ecosystem in which that language will exist, including APIs, tools, and automation. Change is a critical part of operating production software systems, and thinking about how to express and manage change is also a key part of configuration. And finally, ask who are the stakeholders? What are the risks and challenges for each of the stakeholders, and how can the design choices for a configuration system mitigate those challenges and hopefully not amplify them? Hopefully this was enticing enough to get you to watch the longer version of the talk if you haven't already. You can find me on Twitter at @save_spoons, and I look forward to discussing this in the session. Thanks.